Hannah Mackay here. I hope this finds you well. We're continuing our work on integration, and in this video looking at functions of the form ax plus b. Anything more complex than this in our Year 12 Math Methods course is beyond the scope of our course. So you just have to be on the lookout for these types of ones for now. If it's a quadratic or something like that within the brackets, we don't handle that. So we've got 4 extra rules here. The thing to note is if you have the power of a linear function, you raise the power by 1, hence the k plus 1, and put it over that power. And the extra factor is you're multiplying by 1 on a. A is the coefficient of x there. Again, you could always check that by differentiating when you get your answer, because that factor of a would cancel itself out. And the integration constant of plus c each time round too. Let's do 3 examples. So when you see a function like this, you might be tempted to expand out the brackets, but to the power of 4 there's many steps to do and there's lots of chances to make a mistake. If it's a linear type of function here, so an ax plus b, then you can apply this rule. So let's do that. So you keep the function the same, the 2x subtract 7 part. That to the power of 4 is now raised to a 5 and put over 5. And out the front we're multiplying by 1 on the a, which is 2 in this case, and plus c. We tend to just tidy up by writing 1 on 10 and the function again with or without that multiplying between the plus c. As you know, you could also write that divided by 10 and combine them, and they're both the same. The next one, an e to the x function. I don't know about you, but I tend to like things exactly in the format that the rule appears, so I'm going to write that as e to the power of negative 2x plus 4 dx, so that it's quite easy to see it's in the ax plus b form. Otherwise you might be tempted to, in the heat of the moment, to do something and make an error. Now you stop writing the integral sign, and for an e function you copy and paste what you saw there, the 2x plus 4, and then you're multiplying it out the front by 1 over the a value, so that's negative 2. And don't forget, plus c. We tend to tidy this up. That negative we tend to write on the top or out the front. It's just a bit of a maths convention, as you know with negatives. I'll just put a refresher over here, that the negative on the top is equal to the negative at the bottom, and that's also equal to the negative out the front of the numerator and the denominator. Either are fine. It just tends to be maths convention that we tend to write it the first or the third. And the last one is a trig function here. So we're starting off with a sine function, and you come and have a look, and that integrates to a negative cos function. You could always check that by differentiating a cos function, which gives you negative sine, hence why we need to have this negative sign in here to prepare for that. Although this is not with the form ax plus b, like it's really easy to spot because the b is a plus 0. But as you know with trig functions, it's quite common to get this sort of multiple, this 3x in here, or a 2x, or any multiple of x there. So be on the lookout for that. Let's do it one step at a time. So the sine function is going to integrate to a cos, obviously with the negative there. The 2 is going to stay, and I'm going to put the negative with the 1 on the a factor here, so that's 1 on 3. And then the next part here is the cos function. So cos is going to integrate to a sine function. You copy and paste 4x plus pi. Don't be nervous the fact that pi looks like a symbol. It is, but as we know, pi is a number, about 3.14. So it is in this ax plus b form, and we must go 1 over the a, so 1 over 4. And then we tend to tidy that up. So we're going to have negative 2 on 3 cos of 3x plus a quarter sine of 4x plus pi, close the bracket, plus c. Don't forget your plus c. So join me in the next video for definite integrals. Thumbs up and subscribe to the channel. Thank you.